Students, this is the Design Your Own Periodic Table Lab, and I'm doing this as a screencast rather than a video so that you can see me manipulate the images on the screen. The idea here is we're pretending that you're a secret spy and you've got photographs of suspicious characters, which your task is to arrange these pictures in such a way that you find patterns. One of the pictures is labeled blank square. That is, we're deliberately withholding the image that should go there. And our hope is that by playing around with these images, you'll see the pattern and be able to predict exactly what it looks like. We're also going to ask you to draw the next few characters in sequence. So in the intro to the lab, it says, imagine you had the numbers from 0 to 99 written on little squares of paper and were asked to arrange them. Well, one natural way to arrange those numbers would be from 0 to 9 in the top row, from left to right in order, and then from 10 to 19, 20 to 29, and so forth. And that way, every digit within a column ends with 0, or every number in a column has a digit that ends with 0, and every or the left column and the next column over would have a number whose digit ends with 1, and so forth. Similarly, in every row, every number would begin with the same digit. So you'd have the sub 10 numbers, and then the 10s and the 20s and the 30s and so on. Well, we're going to do that with these pictures. And in doing that, you might say, okay, what's the point other than that this is a puzzle? Well, think of the Russian chemist Dmitry Mendeleev, who in 1869 developed our very first version of the modern periodic table. What he had access to was information about each of the different elements, things like their reactivity, their melting points and boiling points, their average mass, and so forth. And what he did, he literally had cards that he was arranging into patterns. And his genius was that he was able to leave blank spaces, or he thought to leave blank spaces for the elements that hadn't been discovered yet. He was even able to predict the properties of those elements. So one of our pictures in this lab is indeed a blank square. We're going to be Mendeleev. Okay, with that as the background, let's take a look at some of these images. Notice that they all have easily identifiable characteristics like number of hairs on the head, number of arms, number of fingers on the hands, easily visible sizes of their bodies along with body patterns. And if you take a close look, you can even see differences among the characters in their degrees of smiliness. So you can go about this in many different ways, but one way I would suggest you think about this is, let's take one of the characteristics, say number of arms, and I'm going to group all of the characters with a given number of arms together. So over in the right corner, lower right corner of the screen, I'm just grouping together characters that have 3 arms. I'm going to put the blank square maybe way up in the corner for now. I see a lot of characters with 2 arms, so I'll group those together. And there are just 2 characters with 1 arm. You can see those in the upper left. So if I'm basing this on, okay, what are some of the similarities here? Well, for among the characters with just 1 arm, I see one of them has 1 hair on the head and 1 finger, and the other one has 2 hairs on the head and 2 fingers. The patterns on their bodies are different. One has a square on its body, and one has an upside down triangle. Okay, so I might think, all right, those 2 are interesting. If I glance down to the characters with 2 arms, I notice that one of them also has a square on its body. I might just look at that. So like pattern on the body is an interesting one to think about. the next one, let's see, I'm looking at an upside down triangle, and I'm just trying to group these with similar body shapes. Here's one with a shape, I'd call it a quatrefoil on its body. One has 3 dots. One has kind of a fish scale body pattern. One has like polka dots. One has a checkered pattern. One has upward pointing triangles. Okay, so I'm just lining them up at first. And then among the characters with 3 arms, let's see if we can find some matches. The one with an upside down triangle, I might put in the column with the other upside down triangles. The character with a square on its body, I'll put in the same column as the ones with squares. Quatrefoil will match. The number of dots, 3 dots on the body. The fish scale pattern, what looks like polka dots, and maybe a checkered pattern. Notice we have a missing character here with the 2 upward pointing triangles. That could be a nice candidate for the blank square. In fact, I might just drag that down into that column. Okay, so now we've got something shaping up here. Let's take a closer look at some of the other characteristics, like number of hairs on the head. Okay, in the leftmost column, all of the characters have 1 hair on the head. And then in the next column, it gets kind of weird. There's a character with 2 hairs on the head in the top row, but then the other characters have, if you count them up, 8 hairs on the head. In the next column over, 7 hairs on the head. And then the way I put this here, 4 hairs on the head in the next column, 2 hairs on the head on the next column, followed by 3, followed by 5, or 4, that's 6. 6 followed by 5. Other things you can look at. You could look at number of fingers on the hands. That is on the number of hands, fingers on the hand that's the newest hand. So for instance, in the top row, there's only 1 hand there, and the number of fingers on the characters are 1 and 2. But in the next row, if you glance across, they all have 2 fingers on the right hand, but differing numbers of fingers on the left hand. The character on the left has 1 finger on the left hand. The next one has 8, and then 7, and then 4, and then 2 on the left hand, 3 on the left hand, 6 on the left hand, then 5 on the left hand. In fact, the number of fingers on the left hand in the second row matches the number of hairs on the head. I wonder if there's something to that sequence. What if we were to rearrange these characters with increasing numbers of fingers on the left hand as you move from left to right? So I'm going to do a little bit of reshaping this to get them in going from number of fingers on the left hand from 1 to 2 to 3 to 4 to 5 to 6, 7, and 8. And then if you look at the third row, I'm pulling that blank square down for a second here. Notice that in the third row, every character has 2 fingers on the upper right hand. They all have 8 fingers on the hand on the left, but they have differing numbers of fingers on the hand to the lower right. Students, what if we followed that same pattern of increasing the number of fingers on the new hand from left to right? Take a look at what happens. Hey, we have reshaped this so that the number of fingers on the new hand is the same within a column, but that also matches the number of hairs on the head within a column, which also happens to match the pattern on the bodies within a column. There's a goofy one in the upper, this element here. You might say, hey, by virtue of the number of fingers on the hand and hairs on the head, it ought to go in column 2. But then you might say, but based on body pattern, it ought to go in this last column. Students, think about helium on the real periodic table now. In the real periodic table, helium is classified as a noble gas because of its reactivity. It doesn't bond with other elements. However, unlike the other noble gases, it only has 2 valence electrons, whereas the other noble gases have 8. Oh, isn't that curious? Helium, by some measures, ought to go in column 2, at least by virtue of number of valence electrons. But if you say to yourself, well, the reactivity of helium is more important than the actual number of electrons, valence electrons, then we should put it with the noble gases. Usually chemists come to that later conclusion, and they put helium with the noble gases. It's kind of like in this exercise, you might say the character with the 2 hairs on the head and 2 fingers on the hand might in some ways belong in column 2, but based on body pattern, it ought to go in the column on the right. One last thing I'd like you to notice, within a column, as you go from top to bottom, the characters get fatter, don't they? They go from being skinniest at the top to being wider at the bottom. And that pattern holds true throughout. So with that, let's take a look at the blank square. If we know that the blank square belongs in the row with, or in the column with 5 hairs on the head, and again, your artistic ability is not what we're looking at, then we ought to see a character that's pretty wide and that has in its body pattern 2 upward pointing triangles. It ought to have, the other thing we should look at within a row, if you look at degree of smiliness from left to right, they all match from extremely frowny on the left to somewhat less frowny to a medium frown to a neutral to a slight smile to a medium smile to a more significant smile to absolute elation by the time you get to the right. So I'm looking at the character for the blank square. We ought to see a moderate smile. Now for number of fingers and number of arms. It's in the row with 3 arms. Oops, I want to undo that one. It's in the row with 3 arms. And in the arm for every character in that row, 2 fingers on the arm to the upper right, 8 fingers on the arm to the left. And then the number of fingers on the arm to the lower right ought to match the sequence. So we've got 1 finger on that hand, 2, 3, 4, then the blank square. Well, what comes after 4? 5. So I'm going to draw 5 fingers on that arm. And then it would continue in sequence. 6 fingers, 7 fingers, 8 fingers. So our character for the blank square looks like this. Another challenge they ask us to accomplish in the lab report is to draw the next 3 sequences. Draw the next 3 in sequence. So if I were asked to draw in row 4, column 1, I would show 1 hair on the head. I would show a really fat body shape with a square on its pattern, on its body as part of the pattern. And we ought to see a total of 4 arms. If you're following the pattern, here's a 1 arm, 2 arms, 3 arms. Here we ought to see 4 arms. Now on those, on the hands at the end of those arms, we should have the appropriate number of fingers. So all of the characters in this row will have 2 fingers on the arm to the upper right, 8 fingers on the arm to the upper left. In row 3, we were filling the number of fingers on the hand in the lower right, should be 8. And then in the new arm with a hand on it, we ought to have the same number of fingers as the column. So I would expect there to be one finger on the arm to the lower right, or lower left, rather. And then in this box, I'm going to draw it kind of up above, we would expect a character with 2 hairs on the head, with a somewhat less frowny face, so like a medium frown. Again, a very fat body shape. We would see like the fish scale pattern, which I'm not going to be very good at drawing, but it'll look like the other body patterns. And it will have 4 arms. It will have an appropriate number of fingers on those arms. So if you remember the pattern here, it was 2 to the arm on the upper left, followed by, if we've filled this entire row for the arm to the upper left, 8. The arm to the lower right would get its 8 fingers. 1, 2, 3, 4, 5, 6, 7, 8. Okay. And then just 2 fingers on the arm to the lower left. And then that pattern would advance one more finger on the arm, a somewhat less frowny face, polka dot pattern, and 3 fingers on the arm to the lower left in that last position here. Thanks for your great work with this lab. It's kind of a fun one, and congratulations on building a periodic table.